Now that you have learned all three forms of the quadratic equation, we want to start talking about solving quadratic equations. And there are actually three methods to solve them, and they have something to do with the three forms of the quadratic equation. When we talk about solving a quadratic equation, we are talking about when that quadratic equation, when the parabola crosses the x-axis. And so you can see that there are real-world applications. For example, when the angry bird will hopefully hit a piggy, but will hit something on the ground, or when a rocket that is launched into the air will also hit the ground, and at what time that will be. So when we talk about solving quadratic equations, we are finding the solutions. We are finding the solutions when y equals 0, i.e., when the parabola crosses the x-axis. So when we look at these three examples, because today we're going to be talking about solving quadratic equations using factored form, you can see that two of these equations cross the x-axis, or at least touch it, and one of them doesn't. This parabola will have one solution. It's a perfect square, and it will have one solution of -1. This parabola will have two solutions of 3 and 6 because it crosses the x-axis twice, and the final one will have no solutions because it does not cross the x-axis. Because again, solutions, roots, zeros are all about where a parabola crosses the x-axis. All of these four words mean the exact same thing. When y equals 0, what are the possible values of our parabola? So let's look at a couple examples. When we look at this example, this is in factored form. We have the quantity x plus 3 times the quantity x minus 4. So we know that if we're finding the solutions, we need to set this equation equal to 0. So I'm going to set it equal to 0, and I know that I'm multiplying two binomials, right? Two quantities in parentheses. So based on the zero product property, one of those binomials has to equal 0. Because if I have two quantities multiplied to equal 0, one of them has to equal 0. It's possible that both of them could. So I'm going to set up two equations that equal 0. These are straightforward equations, either x plus 3 equals 0 or x minus 4 equals 0. I'm now going to use inverse operations. For the first one, I'm going to subtract 3 since we had added 3 from both sides, and we get x equals -3. For the second one, we were subtracting 4, so if I add 4 to both sides, I get x equals 4. So now, if we graph that equation, you can see, sort of, that we have an intercept at +4 and -3. And you can see that relationship between -3, when our factored form is +3 minus 4, we're going to have solutions of -3 and +4 because each of those need to equal. Let's look at a few other examples. In this next example, we are not currently in standard form because we know this needs to equal 0. So sometimes you need to rearrange things. I need to get rid of the 15 over here, so I'm going to subtract 15 from both sides. Now I have x squared minus 4x minus 12 equals 0. Now I need to factor this. What multiplies to -12 but sums to -4? I know that if I multiply -6 times +2, I will get -12. I will also get -6x plus 2x to get -4x. I've factored it correctly. I set up my two equations. I use inverse operations, -6 plus 6, +2 minus 2, and I get our two solutions. I can graph it, and I can see that we have solutions at -2 and +6. I could also plug these back into my equation and make sure that I get a solution that equals 0. 6 minus 6 equals 0, so that's a check, and -2 plus 2 equals 0, so that's another check. Another example, this is a quadratic equation, but we have no c value. So I can't factor it the same way I did over here, but I can take out the greatest common factor, which is x. So if I factor an x out of both of these two terms, I have x times x gives me x squared, x times 2 gives me positive 2x. So I know that either x equals 0 or x plus 2 equals 0. I solve the second one in the same method. I have our two solutions and I can graph it, and I see that our parabola crosses the x-axis at 0 and -2. Finally, in this one, our a value is not 1. We have lots of other numbers, so these are two-step equations, but we solve them the exact same way. So I know that either this binomial or that binomial equals 0. So first, I'm going to add 2 on this one to get rid of my constant. Over here, I'll subtract 4. So now we have 3x equals 2, and you know that 3x means 3 times x. So I divide both sides by 3, and I get x equals 2/3. Over here, we have 2x equals -4. The inverse operation of multiplication is division. I divide both sides by 2, and I get x equals -2. When we graph it, we can sort of see that we have an intercept at roughly 2/3 and also -2. I hope this video helps you understand how you can solve quadratic equations using the factoring method.